we are at the last section of Chapter 2, which means probably tomorrow some time to review. Monday we're kind of looking at a quiz. I'm going to just remind you or just kind of tell you, I guess, that Chapter 2 test will be Tuesday, okay? So again, tests are 30% of your grade, so are they a big part or a small part? Big. So that'll be coming for you on Tuesday. So probably a short quiz Monday, big test on Tuesday. So you might want to be thinking ahead about that right now, okay? Any questions about that? All right. Hey guys, we'll get started. Does everybody have their 2.9 notes in front of them right there? Okay. You probably will want a calculator out today. I don't care if that's in your phone or whatever. I'm going to pull my calculator out right now. Okay. And guys, we're going to get on this idea of square roots and cube roots today. Yeah.
Why did you have like
All the scientific, I'm in scientific notation.
No, I'm talking about there's like a big black thing.
Where?
Like ours has this.
Yours was gray. Can't read mine, can you? Didn't scan very well. I'll figure it out.
I can kind of see it.
Kind of see it? Yeah, we'll get it there.
I feel really close to the Oh yeah. What are your best words about it's so much brighter.
It's bad, isn't it? We need it too.
You can be like this light
No. Okay, let's rock and roll here, guys. Title, square roots and cube roots. I'm just going to ask you a question. Square root of 25, what is it?
5.
5. Okay, why is it 5? Well, because a positive 5 times a positive 5 is what value again? 25. Now, you've heard of square roots. I don't doubt that, all right? Square root, basically, what number times itself would make the value you're trying to root out, right? Okay. Let's see, how many 5s made up that 25? 2 of them. Okay, so what do you think a cube root is? It's a number that you would multiply, or if I said, here's the deal, how about I said this, cube root of, say, 27. What if I told you the cube root of 27 is 3? Anybody know what that means? It means 3 times 3 times 3. Instead of having just 2 values that multiply up to what we're trying to root out, cube root is going to mean what value would you have that 3 of those would make that. So for instance, cube root of 27, check it out. What's 3 times a 3? 9 times 3 more would be 27. So if I say, what's the cube root of 27, you would tell me 3. Okay. There's going to be some goofy stuff in this section. For whatever reason, this section is just different. It's very easy, but sometimes there's just some weird stuff in here that will make you make some funny decisions. And I'm going to try and help you with some charts today to help you make better decisions in terms of what we're asked. So, square roots and cube roots are going to be a focus. Looking at finding square roots and cube roots. And then you're going to get this idea of rational and irrational number. How many of you guys have heard the term rational before? You've heard of rational. Anybody ever heard of irrational? You've heard both terms, right? Anybody know the difference between a rational and irrational number?
Rational, you can break up.
Rational, you can break up. Like, what do you mean there?
Like, can't be like, it's like broken, like, it's like broken into like negative.
Kind of.
Maybe times as well.
No, I think you're thinking of factors and prime numbers there. I'll show you what that is here in a second. I'm going to give you a cheat sheet to work this, all right? Well, let's run through some terms here real quickly, okay? First key term, square root. It says 1 of 2 equal factors of a number, all right? 1 of 2 equal factors of a number. Right here, gang, we talked about this idea of the square root of what value first? Square root of 25. And you might want to write down what I'm putting in here today. But the square root of 25, what did you guys say it was? 5. Okay. Now read over here in this illustration for me. Read that illustration. It says in the illustration that both 5 and what else would work?
Negative.
Why would negative 5 work as a square root of 25? Because if I work backwards, a negative 5 times a negative 5 puts you back at that positive 25. So the thing I want you to understand about square roots is they can either be positive or they can also be negative. So as an example, if I say what's the square root of 49, you would say it is positive or Negative 7. Can you guys see this chart up here okay? Can you guys see these numbers up here? What did I say? 49 was my value? Can you guys see that back there? All right, if you can't, I would encourage you to get to an eye doctor first. All right. Secondly,
There's glare on it.
I see it.
Yeah, there's a lot of
there's
glare.
glare.
that's because I'm glowing today. All right.
You do.
You're like blinded.
You look pretty snazzy.
You are snazzy.
Square root of 49, what value is that?
Snazzy, snazzy.
7, right? But it could also be what kind of 7? Negative 7. When you do square roots today, I want you to start getting in the habit of writing my solution has plus, whoops, I didn't want to do that. This is what I wanted to do. You might start saying the solution is plus or minus 5, okay? Now, obviously, if you forget the plus or minus, I'm not going to get too picky about it, but I will remind you and say, hey, what about square roots? They can either be positive or they can be negative. Okay, now, I'm going to kind of skip around right here. First term I talked about was square root. I want to jump down to cube root then. If a square root was one of 2 equal factors of a number, then cube root says one of 3 equal factors of a number, okay? And the idea here is this. It says since 3 times 3 times 3 equals, what's it say here? Then 3 is considered a cube root of 27. Here's how you're going to see cube roots listed in your problems today. I'm going to say the cube root of 27, okay? What do they use as this superscript out here? Looks like a square root sign, but they just put what above it? A 3, okay? And what value do they get for this? I only get 3. Now, a cube root's only going to have one answer. Square roots could either be positive or what? Negative. Cube root, not the case. Because if you go negative 3 times negative 3 times negative 3, what's a negative times negative to begin with? Times that third negative would back to a negative. Would that work for us? We were looking for cube root of positive 27. So a cube roots, that's it. Here's a question. See if you can get it. What's the cube root of 125? Anybody know it? Cube root of 125. 5 is your guess?
Negative 5.
Negative 5 or positive 5? Let's check. What's 5 times 5? 25 times the third 5? 125, okay? How many of you guys have a calculator that looks like this? Oh, do you guys have a button that looks like this? It's got like a square root button up here, but it's got the X and then a square root and then a Y on it. Do any of you guys have that button like this one right here?
I go and
You don't think so?
Yeah, I do.
Okay, some of you might have a calculator that works like this. I said cube root of 125, right? Oh, I'm trying to think of a number that's both perfect cube and a perfect square. Oh, I got it. You ready? 64. What's the square root of 64? Does that say square root right there? Oh, I got a calculator that does cube root. So where's the square root sign? Well, you know what? I'm going to use this XY button right up here, okay? 64. You darn thing. Where's my clear button?
Up, 9, down.
64 I'm going to start with. Do you guys see like this X and then a square root and then a Y out here? Do you guys all have that? If you hit that button and then hit 2, I think. Yes. Anytime you do a square root, you push a 2 in. So does it work?
Well, mine didn't, I didn't even have to put it to it. It just did it.
Okay, if it just does it, then you got the square root key for it. That's perfect. All right. My concern is cube roots. If you have like this XY key and now a cube root button down here, here's how you would do it for 64. The cube root of 64, I'm just going to tell you, is 4. Okay. Here's how you would do it. You would hit this square root button of X, and then there's a little Y out here as your superscript. I want what root this time? What root do I want? So what value am I going to punch in after I've hit that button? Cube root of 64 is what then? 4. Okay, if you run into trouble finding square roots or cube roots in your calculator, please let me know. Question? Where is your calculator? On your phone? Do you guys have an Android?
Yeah.
Did you guys download the graphing calculator?
Yeah, I did.
Okay.
That might be-
I will show you when I get down with the notes here where to go with that. That sound good? And because it's really slick, I'll show you which one to put on your phone. It's a free app. It works really well. Okay.
Not for us, for Apple.
Wait.
The iPhones, you know what?
It's 996.
We'll talk here in a second, okay? But just get the idea down. You know that a cube root is a number that's a factor of itself how many times? Or has the same factor how many times? Cube root, how many?
3.
Square root? Okay. We'll talk about rational and irrational numbers here, but oops. First number up here is a rational number. All right, here's what I want you to understand about rational numbers. A rational number is any number that can be written as a fraction. Okay? A rational number is any number I can write as a fraction. And when I say fraction, I'm talking about one whole number over another whole number. Like 1/2 would be 1 over what? 1 over what? 2. Okay? 1 is whole, 2 is whole. This negative 0.5 is negative 1 over 2. All right? Rational. Now, I'm going to tell you this right now. We'll look at some examples here in a second. But most numbers are rational. They're going to talk about numbers also being irrational. How about a volunteer to read my irrational definition for me? Lyric, go ahead. Okay. It's a number I cannot write as a fraction. So I cannot write it as a fraction. You might want to jot this down. What's maybe the longest number that you guys know about that goes on forever?
Google.
Infinity. Okay. Pi. Who said pi? Yeah, pi. 3.14159 blah, 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 blah. For a long time. That's a lot of blahs, right?
Does it ever end?
No, it does not.
Then how do
It's
you
irrational.
know what it
They use calculus and they use the idea of indefinite intervals to find out what value that would converge on as your upper limit tended towards infinity. That would be something to learn about as a senior, okay? All right, cannot write as a fraction. That's how they came up with it. Basically, it's an infinite number of triangles within a circle where you're looking at the length of each side as the number of sides approaches infinity. Want to do that proof today instead? I do. Ivy does. Look at that. She wants to do that. Figure out where pi came from. It didn't come from the kitchen. I'll tell you that much.
Whoa.
All right. I'll show you some examples here in a second. Just remember, rational as a fraction. Irrational, not a fraction. Okay, real numbers. Real number system is any rational or irrational number put together. So real number is either rational or irrational.
So it's a number.
What's that?
So it's basically just a number.
Any number. Okay? Now, funny you would ask that because when you guys are probably juniors or seniors, you're going to run into this idea of imaginary numbers. There are such things as imaginary numbers, but that's a discussion for a different day.
Now
Okay? There's imaginary numbers in math. Did you know that?
I kind of wish I did.
Now you know. Perfect square. Perfect square. You're going to hear me say a lot of perfect squares. You guys see this chart right up here? What's the first perfect square? What am I pointing at? 1. What's the second perfect square? Third perfect square. Is 225 a perfect square? Is it? I got to see if you've got a chart in your book. Hang on one second. Go to page 668 in your book. Page 668, 668 in your book. Go there. Huh? There's one right there. That's mine. Make sure I get it back, all right?
660.
Or did I take yours? I'll take it. Did you give me your book today? You didn't.
I
Okay, turn right to it. 668. Guys, do me a favor. Do you guys see up here how in this chart right here, there's like 3 different numbers in each round or green column, or like 3 columns within each green column? If it's not already there, I want you to see the middle column. What's the word in the middle column for all those green parts? Square. Right above that word square in the middle one, put the word perfect on top of it if it's not already there. How many of your folks already have the word perfect up there? The word perfect, so it says perfect square in the middle of each one. Is it already there? Grab one up back there. I don't care. We're gonna know if we'll put it back there. Okay, guys, I'm gonna run that middle column. I want you to go all the way down to 676. You guys see 676 about halfway down that middle column on the left? Okay, here's the deal. You're going to get questions like this. Is 676 a perfect square? The answer is yes. So I might say, what's the square root of 676? Look right to the left of 676. What number is over there? Guys, what's the square root of 676 to the left? Everybody listening? Go all the way down that middle column on the left here. Go down to 676. Does everybody see where I'm pointing my paper clip at right here? Right to the left here. Then right to the left, there's a bold number in black. 26. So I say, what's the square root of 676? You say what? 26. Is 26 a whole number? Okay, so is 676 a perfect square? Yes. Okay, go down that middle column. I'm going to ask you a question. Is 1,500 a perfect square? Is 1,500 listed in the column I'm going through? So is 1,500 a perfect square? No. That makes sense? Okay. Is 1,600 a perfect square? Okay. You understand the question there? All right. Let's rock and roll. Perfect cube, same thing. A number whose cube root is an integer. I'm going to list some of the perfect cubes to start. You'll want to do the same, all right? 1, 8, 27. Boy, you're going to test them here today. 64, 125, 216. Oh boy, oh boy, oh boy, oh boy. I'm at 7, 343. 8 would be a 4, would be 512.
How do you know these?
Huh?
How do you know these?
I just do. And if that makes me weird, I'm sorry. But you've known I'm weird the whole time. Those will be the first 10 perfect cubes. Okay? 1 times 1 times 1 is what? 1. 2 times 2 times 2 is 8. So the cube root of 8 is 2. This is my third one. Cube root of 27 we've already discussed. So this is my fourth value. What's the cube root of 64? 4. Not square root, cube root, right? Okay, 4 times 4 times 4 is 64, right? So the fourth value in 1, 2, 3, 4, the cube root of 64 is 4. Okay? All right. Let me know that you've got that list down for some of the perfect cubes right there. 11 times 11 times 11, 1,331. That's the next perfect cube.
3,031.
1,331. 1331. Yep. 11, 11, 11. All right. You guys have that down?
Yeah.
All right. Down at the bottom right here, it says square roots and types of numbers. It says the square root of a number is one of 2 equal factors of the number. It says a number that is equal to the product of 2 equal integers or equal integer factors is a perfect square. Every positive number has both a positive and a negative square root. We kind of talked about this already. Don't read too much into this. We'll look at some examples to make sense of this. Okay? Questions about the terms, first of all, gang. Rational, irrational, makes up all real numbers. Square root, cube root, you're going to hear a lot of that. Perfect square, perfect cube, you'll hear stuff like that. All right, just keep those in the back of your mind. Page 2, please. All right, let's rock and roll. This is where a calculator is going to come in handy, gang. Just get used to it. Now, I know I give you the sample responses down here, of which I can't read, but find the square root of each number. So the first number they tell you to punch in is 0.01, right? And don't they want you to take the square root of that? They do, don't you? I've got my square root key up here. You guys see my square root key up here? Yeah, I couldn't find it. How, did you know I was there the whole time? Oh my goodness. What do you guys get for the square root there? 0.1, right? So I'm just going to go ahead and put 0.1. As it's a square root, though, what should I probably put with it? It's either be positive or it could also be negative. Square roots can be positive or negative, so you might want to put plus or minus up there. Okay? What do you guys get when you take the square root of 6.25 in your calculator? What do you guys get for the square root of 2 point how much? 2.5? And since it's a square root, I'm going to go plus or minus. How about 121? I've got 121 on my chart. Can you guys read where I'm pointing? What's the square root of 121? How much? 11. Because 11 times 11 would be 121. As it's a square root, what should I probably choose to put in front of the 11 again? Plus or minus. Yes. Okay, so let's look at some examples that might differ from what we kind of already know here. Jump down to the first 3. All of a sudden here, gang, they start getting a little tricky here. What's that say? 189 is that what that says? Or 169?
169.
169? Okay. They start throwing some fractions at you, don't they? Okay, no worries. We're going to square root the 149th right here, gang. We're going to square root 149th. All right. How do fractions work for square roots? Anybody got an idea? Well, don't you have a numerator and a denominator? Okay. So take the square root of the numerator. What's the square root of 1 up top? 1. And I also probably want to take the square root of the denominator on the bottom. What's the square root of 49? So the square root of 149th will be what? 1/7, putting what and what out there? Okay, you guys try 2 and 3 on your own. See what you get for solutions, all right? I want the square roots of those two values. G-O, go.
How is that in drinking your coffee?
You spit in it, Megan.
Yeah, sorry.
Yeah. All right, let's look at this. So type in, what's the next number? 2.25. Got it, kiddo? Good. Guys, my goal by the end of the day when I turn you loose on some work, if you're not sure about calculator stuff that you're using, bring it to me so I can get you on the right track, okay? Make sense? Give me a show of hands. How many are like, I'm not sure yet? Okay, bring that to me as soon as I get done with this, okay? Get the notes down and bring it to me as soon as you can.
So like
This is the best calculator ever. Are you being great too, kiddo?
what is it with fractions?
Push on. And I'll show you where it goes. There's a tab down the bottom. Open it up. It's more of a science. Get into the scientific part. You don't have it. Okay. Square root of 2.25. What'd you guys get? 1 point what? Okay. 1.5 plus or minus. How about the next one? You had 169 over 81. What'd you get, Megan?
13 over 9.
13 over 9 plus or minus. Okay, how you guys feel about this? Pretty easy, isn't it? Okay, now the part that I think that we really need to focus on is right here. This part, this can be goofy. What's rational, what's irrational? What I would like you guys to do, isn't the back page blank for you guys?
Yeah.
Okay, go to the back page, blank. Rational versus irrational. Okay. Think of numbers in terms of decimals, okay? Think of numbers in terms of decimals. Okay, we already said rational numbers can be written as a fraction. Okay? So an example might be 3 over 5. Okay, that's rational because I can write it as one whole number over another whole number. Do you guys agree with that? Okay, fractions. Rational numbers can also be a whole number. Give me an idea or an example of a whole number. 13, I heard. 13 can also be expressed as 13 over what?
1.
Fraction, right? Everybody agree? Okay. You can also say that a rational number is a repeating decimal. So I'm going to say a repeating decimal. Do this for me, please. First of all, I'm going to give you an example of a repeating decimal right here. Oops. Give me a second. An example of my repeating decimal.
You changed it.
0.6? No, I didn't. It says repeating decimal.
No, it looked really cool.
Oh. Oh. Well, it is kind of cold here, as I said, right? Some people said it was hot in here,
Yeah, it was really hot.
It's kind
which I responded, I can believe.
I can teach class.
All right, rock and roll. Let's go on this. Hey, 0.6 repeating. Why in the world can I write that as a fraction? Well, here's the question. Who's got a calculator? I have a calculator.
Oh wow.
Watch this right here. Watch what happens right here when I go 2 divided by 3. I'm going 2 divided by 3, right? Isn't 2 divided by 3 like a fraction, 2 over 3? Aren't fractions really division? 2 divided by 3. Oh my goodness, what's repeating the whole time?
6.
What does the calculator do when it finally runs out of
Rounding
space here?
up.
Rounds, doesn't it? Okay. Now, if this calculator, if this window went on forever, what would you expect would happen here? 6 is all the way through here. Are my 6s repeating?
Yes.
Yes. So there's a 7 on this. If you fill up a calculator window, I want you to get in the habit of not even looking at the last digit. Don't even look at it. So what am I not going to look at?
You can see it on your finger.
Cover my finger. Okay. There.
So bad. Now what? Did we cover the rest?
Here.
Yeah, cover that up. That's better. Okay. Don't look at the last digit. Does that repeat? That 0.6 repeating was coming from what divided by what? 2 divided by 3. Okay. Is 2 over 3 a fraction, gang? Well, it is. We said any fraction is what? Rational. Well, this repeating decimal came from a fraction, didn't it? So anything that repeats is also what?
Rational.
Okay. Here's another one. The word I'm going to use is terminate. It terminates or it stops. In other words, it fits in your window and it doesn't completely fill it up. So here's an example. It terminates. Let me think of a good one. Oh, I know. 2.25. All right, I'm just going to tell you where 2.25 comes from. Watch this. I'm going to punch in 9 divided by 4. Is 9 over 4 a fraction, first of all? It's an improper fraction, right? I'm going to hit equals. What's that equal? Okay, first question. Does the 2.5 repeat? No. But does it fill up the whole window? Does it fill this whole window up right in here? No. It actually stops right after the what? That's what it means to terminate. So I got this decimal from 9 divided by 4. So anything that terminates will also be what? Rational. Here's the deal. What the heck is irrational? No repeat. No repeat. No terminate. So no repeating pattern in this. And no termination. And when I say no termination, it means it's going to fill your window up, doesn't it? Here's an example of a number that's not rational or irrational. Write this down, please. Square root of 10. Okay? Quick question. Is 10 one of my perfect squares listed up here? Let's see, 9 is listed and 16 is listed, so is 10 listed? Okay, go to my calculator right here. I'm going to punch in square root of 10. Oh.
Oh boy.
First of all, did it fill my window up? Yes. Okay, something that long is filling my window up, right? I see some 2, 2 repeat, but does the pattern go on forever, or is it just random numbers here? Random. Is there any repeating? Answer is what? No. Did it fill the window up? Well, there's 2 3s, but is that going on in just one part or through the whole part? See what I'm saying? Okay, what are you going to say about the square root of 10? It is what? Irrational. So here's a question for you. I want you to punch these in. Square root of 12.25 and square root of 12.5. Punch them in. See what you get. Tell me if they're rational or irrational, I guess.
I know the first one.
What's the first one?
Rational.
Why is it rational?
Because it ends up 3.5.
When I take 12.25 and take the square root, does it terminate?
Yes.
It stops after the 5, right? So what's that going to be? What kind of number? It's rational. Okay, it's rational. How about if I punch in 12.5 and rip that out? Uh-oh. What kind of number is square root of 12.5? Irrational. Okay, probably the most famous number that's irrational is pi, isn't it? Starts at 3.14, goes on forever. Is there any repeating in that decimal? Answer is what? No. Pi is irrational. Okay?
So basically, irrational means to
Go on forever and not repeat. Right? All right. Kind of a crash course in that. I want to finish these notes up here quickly. Questions about rational, irrational. The number 17, rational or irrational? Rational. Stops. Do you see my poster up here with the number E up there? You see that poor guy writing that number? 2.7, blah, 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 blah. Oh my gosh, look at the explanation in the black part of the poster. It says E is an irrational. We'll talk about that in 2 years as well. Exponential growth. Okay, let's get back to the notes. Any questions so far, gang? I know I'm going quickly, but does it make sense? Any questions?
No.
Where are we? You guys do these 3 on your own right here. Tell whether each number is rational or irrational. 4, 5, and 6. 4, 5, and 6. Let's just look at the first one. What's this bar mean above the 6? It repeats, right? Let's see, repeaters. What did that fall at in your chart? Rational or irrational? It's rational. Good. Okay, punch in the square root of 1.44 in your calculator for the second one. Square root of 1.44, what do you get? 1.2. Does it terminate or does it go on forever? Does it fill up your whole window?
No.
No, it stops, doesn't it? So it terminates, it has to be what type of number?
Rational.
Rational. Just take the square root of 8 for me in your calculator. Take the square root of 8 in your calculator.
No, it's irrational.
Is that an uh-oh?
Yeah.
Uh-oh.
Uh-oh. What kind of number is that then?
Ugly.
Okay. This is the best way to describe it, and you're kind of right on that. You just took the words right out of my mouth, Megan. Rational numbers are the good-looking numbers, okay? Irrational numbers are the ugly numbers.
So are you irrational?
I am irrational. Very irrational, okay? At least like kids got my brain, though. At least my kids got my brain.
Oh yeah.
They don't look like me at all.
But at least
Anybody see Annie come in yesterday?
I think the oldest one looks the most like you.
I agree. Poor girl.
Well,
Okay, 7, 8, and 9. I want to talk about just one of these real quickly. Let's circle this one right here. Do you guys see your square root chart in your book again, please? It says estimate each square root within a range of 1 or 2 interval or integers. Then use a calculator to find the square root to the nearest hundredth. Here's how this works. Guys, go down your perfect square column again, that middle one in the first green section. Is 72 going to be listed there?
No.
What 2 numbers would 72 fall between? 64 and 81. What's the square root of 64? 8. And what's the square root of 81? So since 64 is a perfect square to the left of 72, and 81 is a perfect square to the right of 82, and the square roots of each involved are 8 and 9, square root of 72 is going to have to be between what two integers? 8 and what? 8 and 9, okay? So that's the first part. They're going to say, what is it between? They'll say it's between 8 and 9. Now punch in the square root of 72 and tell me what you get to two places. Maybe if you got it, kiddo. Square root of 72. Got it?
Yeah.
Just the two places after the decimal. 8.48. That's all you need to put. So it's between 8 and 9, and its estimated value is about 8.48. Ivy, when you punched in the square root of 72, was that a rational or irrational number? Irrational. Good. Guys, I think you can handle this, all right? Let's run to the last page. I've got one more thing quickly, and we'll call it good today, okay? Any questions about how to do this? A lot of calculator strokes, right? Right? Okay. Last page here quickly. Guys, it says exercises 10 through 13. Choose the letter of the point on the number line that it matches. Let's just kind of punch these in here, see what the values are, and then we'll match them up. What's the first root I have to find, guys? Is that a cube root or is that a square root? Cube root. Now, if you're not sure how to do cube roots, I'll show you how before you walk out of here, but I'll punch it up here real quickly. You guys tell me what you get for the cube root of 9. Anybody get a value to that yet? 2.08 about?
Yeah.
Okay? I'm going to write this down below here, 2.08. Guys, of A, B, C, or D, which one looks like 2.08-ish? Letter B. Okay? What's the next value? The cube root of 100. Isn't 2.08 going to be right about here, gang, on that number line? Give me some sort of sign that you're alive right now. Okay? So the cube root of 100, you said, is how much? 4.64, I agree. So which letter is that going to match? B? D. Dog. You go, dog. Okay, now we're square rooting stuff, right? Square root of 13. I get 3.6 for that. So which one looks like about 3.6 up there on the number line? C. So that makes the last one have to be what? A. All right. Guys, last part. It says each measurement is the area of a what? For 14 and 15. So it says each measurement is the area of a what? Square. What happens here is you have squares. What's true about the lengths or each side of a square? They are the same. Okay, if they say here's an area right here and they want the length of this side, they want to know what the length of the side is. If this area inside is 75, let's see, if we're talking about a square, which root do you think we're going to have to use to find that side? A square root or a cube root? Yeah, square root. I'll show you the cube root here if you're not sure here in a second, okay? Just take the square root of 75. Tell me what you get. 8.6 what? 8.66? Okay, here's the dealio on this. If an area on the inside of a square was 75, that would mean the two sides are about 8.66. You guys agree that the area formula for a square is length times width? Okay, somebody punch 8.66 times 8.66 in. Tell me you get really close to what value again? 74.9 something, okay? Which is probably coming from 75 after we rounded, right? Yeah. Okay. Then, guys, right here, it says each measurement is the volume of a what? What's the word?
Cube.
What root do you think you're going to have to take here if they give you a value to find the length of one side? The cube root. So I want the cube root of 512. So some of you in your calculator, you have this root sign with a 3 on it. That would be the cube root sign. But if you don't have that, I'll show you how to do that here in a second. All right? Cube root of 512, what do you get? 8. which would be 8 times 8 times 8, or length times width times height for the volume of a cube would be 512. Each edge is how long? What did we get for that value again? Well, it was an 8. Guys, what questions have you got? I'll reiterate your assignment one more time. Assignment won't be due until when? Page 116 is where it starts. I'm asking you 1 through 41 odd. Due for Monday, so get that down. Do you guys have any questions? What I'd really love to do is, if you've got a calculator that you're not sure of right now, bring that to me. I'll punch that stuff up and make you feel comfortable with that, okay? Because you're going to need it for today's assignment, all right? Due Monday. Any questions? Megan, do me a favor. You see the little blinking red light where it says S on there? Nope, on the computer. Grab the mouse. See the blinking red light down towards the bottom right? Hit that.